On today's episode of Wangel's Workshop, we'll be taking this old rusty file that belonged to my grandfather, and we'll be turning it into a knife that can last in my family for generations. I'll start off by annealing this file, or heating it up to its critical point where it's non-magnetic, and then letting it sit in the air. It'll soften the metal and make it easier to work with. It's my understanding that some files can be turned into a knife without a heat treatment, but I don't own any files like that. All the files that I own are far too hard and brittle to make a knife. They would have a hard, strong edge, but any sideways pressure would cause them to break. So I need to redo the heat treatment totally to make sure that the temper is proper and that the knife can have some flex to it. So now after annealing the file, it's at its soft point. You see now my other file that's still hard will cut it easily. And this allows for it to be easy to work with and actually gives it back some of that flexibility so I don't break it while I'm making the knife. Here I'm tracing out my template and then I'm going to cut it to shape using an angle grinder. If you're enjoying this video so far, please consider giving it a like and subscribing to the channel. I would really appreciate it, and you have no idea how much it helps the channel grow when you do that. Now I'll use my 2x72 to grind off the file texture and finish profiling the knife. If you're familiar with my channel, then you'll know that this 2x72 grinder is new to the workshop. I'm super excited about it, and I purchased it from a guy locally who built it using the Revolution design that Brian from Housework made. It's really been a fantastic upgrade, especially coming from the 4x36 grinder that I'm used to using for making knives. And this is the first knife that I've made start to finish on it. It came with a 1.5 horsepower variable speed motor, and it also goes in reverse, and the whole thing turns horizontal as well. It kind of checked all the marks that I was looking for, and it came at a fair price. Here's the knife after removing all the texture and finishing the profile. Now I need to thin out the tang to make it easier for the fit up. I don't have a proper file guide, so I'm going to use like a makeshift piece of wood file guide, which is definitely not the way to go because sandpaper will remove the wood, so you have to be very careful in doing this. So here's what that looks like. I still need to remove those bottom corners, but it makes it a whole lot easier when fitting up the guard in case the slot is slightly oversized. Now I'm going to use that horizontal feature that I was talking about, and I'll use this to grind the spine and the front edge of the knife parallel to the length of the knife. In this way, when I go to mark out my lines, it's a lot easier to mark them and see them. Now I'll apply this layout fluid to the edges and use a drill bit to mark out my grind lines. Now keeping my elbows tight to my body, I'll start my grinds with an aggressive angle, bringing the bevel up to the marked out apex line, and then I will start bringing it towards the spine. After I finished my first bevel, I was having a terrible time trying to get the second bevel even. And I figured out that the platen wasn't pushed up against the left side of the belt, so it was kind of creating like a slack belt thing going on the left side. Once I made some minor adjustments, it fixed this and it smoothed out the whole process. It's important to really look at your bevels closely and assess them so you can see all the spots where your grinds aren't perfectly flat and where they're uneven in some spots. We can address all this after the heat treat. I don't want to remove too much material now. Now we're on to the false bevels. I decided to go with a file for these, but I actually ended up only doing one of the false bevels with a file, and then decided to go ahead and finish that one and do the other one on the 2x72. Now it's time to heat treat the knife. This forge is also new to the shop. I purchased it off Amazon. It's a 2-burner propane forge for about $230, I think. I'll reserve reviewing it for now because issues that I have could potentially be user error still. I also didn't have the right tongs to do the heat treatment and tried to go ahead with it anyways, but then I ended up using vice grips and channel locks to give myself the proper distance from the forge for the heat treatment. The assumption of this file is that it's made from a pretty standard high carbon steel, so I should be able to heat it to its critical point when it's non-magnetic and quench it in oil, and then follow that up with 2 temper cycles of 2 hours at 400 degrees. And the heat treatment actually came out quite well. This is the handle material that I'll be using. It's ironwood with G10 spacers and some micarta spacers as well. And then for the guard, I'll be using 0.18 1084 high carbon steel. Here I'm marking out where I need to make the slot in the guard, and then I will center punch where I'm going to drill the holes. I don't have a milling machine, so I'll just have to use my drill press and a drill bit as well as some files to make the slot. With the guard fit up, I will make a slot in the handle material. This one doesn't have to be so perfect like the guard does. It can have a little bit more play because it'll be filled with epoxy, but I may have taken that a little bit too far on this one. You'll see why later. Once I'm done on the drill press, I will finish out the slot using a drill bit and a drill, and then using some files. And then once that's done, I will grind down the guard and cut down the handle material so there's not so much to remove once the knife is glued up. Especially with the guard, you don't want to leave the guard too big because when you're grinding it down, it just creates so much heat that you actually have to worry about the epoxy melting in the handle. With all that done, it's time to do the glue up. I will be using West Systems epoxy. And if you noticed, I hadn't drilled the pinhole yet, and that's because when I did the tang, I left a little bit too much space in the handle, so there was movement of the tang. So I wanted to glue that in place before I drilled that pinhole. To set up this glue up, I will clamp the knife in a vise, and then I will slide the guard and the handle material on and use a clamp. And just make sure that everything is as straight as possible and as flush together as possible. And then I'll use acetone to clean up any excess spill out, especially all around the guard. I want to get that all cleaned up because the finish on the guard is already done. Once that dries, I will go ahead and drill the pinhole and put the pin in place. I did this at night to give myself a good start on the next day, so the footage is kind of grainy and not great. I'm also realizing right now that I didn't discuss the finish of the blade or the guard, and that's because I didn't have to do any hand sanding. I actually sanded it up to 400 grit and then used Combat Abrasives surface conditioning belts to finish the knife off in a satin finish. It looks great, and it's another huge benefit to having a 2x72. So now I'll be shaping the handle. I decided to go with a pretty standard Coke bottle shaped handle, and this wheel is your friend. It's a great way to round over the corners and remove a lot of material, but the biggest thing is that you have to keep the knife moving up and down across it so you don't burn into any specific spot too much. Now I'll finish out with some hand sanding, making sure that everything's rounded over and worked in evenly, and then I'll follow that up by heading over to the buffing wheel. For the finish on the handle, I'll be using the white buffing compound with a coarse wheel, and then the green buffing compound with a softer wheel. I'm super happy with this knife and it really came out great, but here's the mistake that I was talking about. I actually bored out the hole for the tang way too wide. And what ended up happening is when I shaped the handle, I ground into that, and you can see it here, but luckily it was filled with epoxy because I did it right. It's almost kind of a cool thing because it's like a window into the tang, but it's obviously a huge mistake, and I am a little upset about it. However, I don't think that it'll affect the structural integrity of the knife, as the epoxy would probably be stronger than the wood itself. So overall, if you don't pay too much attention to it, it kind of just looks like the grain in the handle, but obviously that's something that I need to not do in the future. Now I'm pressing out a Kydex sheath so that I have a way to carry it. Here's how the sheath turned out. I've really been digging this taco style sheath lately, and as far as the clip goes, I basically just cut it to shape and mold it myself and then screw it on like hardware. Now for a little sharpness slash like edge retention test. I know that this isn't like a super scientific or rigorous way to do it, but this is just kind of a quick example. And this piece of wood, it's actually a very, very hard piece of wood, much more difficult to cut than pine. So I kind of like to use it to really test the blade a little bit. I'm really excited about this knife, and I hope to keep it in my family for years to come. Like I said, it was made from a file that was owned by my grandpa, so I thought it'd be pretty cool to have something to pass down in the family. As always, if you enjoyed this video, please consider liking it and subscribing to the channel. And if you want to be notified when I upload new videos, hit that notification bell. Thanks for watching.